Hello everyone, welcome to our Capstone Design Expo. My name is Jerry, the project lead for RocketLynx. The objective of our team was to design, build, and test a hybrid rocket propulsion system and produce a peak thrust of 250 pounds in a 10-second static fire. Our project consisted of three main subsystems, Oxidizer, Combustion, and Nozzle, each led by its own team. Out of the main chemical rocket propulsion systems, even though not as popular, we chose a hybrid one because it is safe, inexpensive, and we wanted to experiment with the concept behind it. Our system was based on nitrous oxide as an oxidizer, due to its self-pressurizing capabilities, getting rid of the need of an inert gas to pressurize the oxidizer flow. The oxidizer team obtained a maximum mass flow rate of 0.16 kilograms per second delivered through our pintle injector. There was a concern of backflow happening before the oxidizer got into the combustion chamber as a result of large pressure variations throughout the system. As a safety feature, our team designed a double valve channel, one acting in the direction of the flow and the second one acting against it. These valves were mechanically controlled by servo motors attached to an Arduino board and regulated by a rotary encoder. With the integration of the rotary encoder, we were able to map out each degree of rotation from one gear to the other. The initial gear ratio was 1:1, with the anticipation of changing the ratio if additional torque was needed to turn the valves. We hoped the gears would behave similarly to a throttling system. Our hybrid engine used HTPB as fuel. Figuring out the regression rate of our system was one of the most challenging aspects. Our system was heavily dependent on the calculations and approach of these last numbers. The mixture of gases in the combustion gas was treated as an ideal carbon dioxide with a specific heat ratio equal to 1.289. The OF ratio was assumed to be around 6. With this information, we calculated a C star of 1102.9 meters per second. Our ignition system used a 12-volt battery supply and was designed with a locking mechanism and double trigger system. The ignition system also included a buzzer and LEDs to monitor the ignition process. The ignition system was directly connected to a pyrotechnic load based on potassium perchlorate and placed inside the combustion chamber in order to get the HTPB hot enough to allow the nitrous oxide to burn it. Internal temperatures in the combustion chamber were high enough that it was a concern for the structural integrity of the aluminum housing, resulting in thermal shocks, increasing the probability for creep in the aluminum. As a safety measure, our combustion team incorporated two K-type thermocouples attached with Capstone tape to opposite sides of the combustion housing. These thermocouples recorded the temperature distribution along the combustion housing, with the expectation of having a much higher temperature right before the nozzle. The nozzle was designed to compress and expand the combustion gases through a CD nozzle, with a conical profile of a 15-degree taper at the exit. It incorporated grooves for two Viton O-rings to seal the combustion chamber. As a secondary protection for the O-rings, part of the nozzle was rounded and closely fit into the phenolic tube that was already to protect the combustion housing. The area ratio was about 2.5 with an exit Mach number of 2.07. The nozzle was made out of isomolded graphite. It was machined and manually lathed at 450 RPM as shown. Our team also designed and built a horizontal test stand and incorporated a single point loadcell and linear bearings. The frame used square steel tubes that were welded together piece by piece. Our project was halted in the middle of the assembly phase due to the pandemic. Even though we didn't get to a static fire test and couldn't validate our propulsion system and approach, we learned not only about the math behind engineering, but the creativity, intuition, and mainly teamwork behind the project. Thank you for watching from the RocketLynx team.